Inside massive factories right now, a new workforce is being trained. They don't sleep, they don't strike, and they're learning to work like humans. A new generation of humanoid robot factories is coming online across the USA, China, and parts of Europe. These are not research labs anymore. These are production-scale facilities, building robots designed to work in real factories, warehouses, hospitals, and logistics centers. This shift matters because labor shortages, rising wages, and AI breakthroughs are pushing humanoid robots from demos into deployment. In the United States, Tesla is developing Optimus, often called the Tesla bot, inside its automotive manufacturing ecosystem. Figure AI, backed by OpenAI, Microsoft, NVIDIA, and Jeff Bezos, is building Figure 01 with a focus on general-purpose labor. Apptronik, spun out of NASA research, is producing Apollo for industrial use. Agility Robotics is already operating a humanoid robot factory in Oregon for its Digit robot. In China, companies like Unitree Robotics and UB Tech are scaling humanoid production at aggressive speed. Unitree's G1 is designed for affordability and fast iteration, while UB Tech's Walker series targets enterprise and government deployments. The UK focuses more on AI software, robotics research, and defense integration rather than large-scale humanoid manufacturing, often partnering with US and European firms. Tesla Optimus has moved from early prototypes to factory-tested units performing internal logistics tasks. Figure 01 completed real-world trials in commercial warehouses in 2024. Agility Robotics announced its factory can produce thousands of humanoid robots per year. Unitree G1 was introduced as a lower-cost humanoid platform aimed at mass adoption, with prices reported far below Western competitors. China has also named humanoid robotics as a national strategic industry. These humanoid robots share several breakthroughs. Advanced AI vision systems allow them to recognize objects in real time. Large language models enable natural task understanding and adaptive behavior. Force-sensitive actuators and electric motors allow human-like walking, lifting, and balance. Multi-camera sensor arrays replace traditional fixed automation. Most importantly, these robots are trained using simulation, real-world data, and reinforcement learning, allowing skills to improve after deployment. In factories, humanoid robots move parts, handle repetitive assembly, and operate in spaces designed for humans. In logistics, they load, unload, and sort packages. In healthcare and elder care, pilots focus on delivery, mobility assistance, and monitoring. Military and defense research explores humanoid robots for logistics, maintenance, and hazardous environments, not frontline combat. Daily life applications remain limited but are actively being tested. The United States leads in AI models, funding, and software-driven robotics. China leads in manufacturing scale, cost reduction, and rapid deployment. The UK leads in robotics research, ethics frameworks, and defense-adjacent AI systems. This creates a global race where software intelligence, hardware efficiency, and factory scale compete simultaneously. Between 2025 and 2030, analysts expect humanoid robots to move from pilot programs to tens of thousands of deployed units globally. Costs are projected to fall as production scales. Some estimates suggest humanoid robots could reach price points comparable to a small car within a decade, accelerating adoption across industries. Humanoid robots still struggle with complex manipulation, long battery life, and unpredictable environments. Safety remains critical when robots work near humans. Job displacement concerns are real, especially in low-skill labor sectors. Governments are beginning to discuss regulations around autonomy, data usage, and accountability when robots cause harm. The humanoid robot factory is no longer science fiction. It is becoming a core industrial asset. The countries that scale production, control AI intelligence, and set global standards will shape the future of work. Within the next decade, humanoid robots are likely